To start our lesson today, I'd like you to take out a sheet of blank paper and see if you can draw the unit circle from memory. So pause the video, do that, and then restart the video and check yours against mine. Okay, this is what your unit circle should look like. Please check carefully and make sure that you have all of the measurements around the edge of the circle correct. Just as a review from last day, remember that this point here where this green circle is where it is, the measure of that angle would be 0 degrees, or if you've gone a full circle around, it could also be 360 degrees if we're measuring in degree mode. But if we're measuring in radian measure, that's 2 pi. Okay, so then halfway around the circle to this position over here is 1 pi. Okay, that makes sense then that the position that is halfway to 1 pi would be half of pi, which is 1/2 pi, or pi over 2. And then of course the opposite then, if that's 1 pi over 2, this is 2 pi's over 2 right here. So then it makes sense that this position down here would be 3 pi's over 2. And back to full circle around is really 4 pi over 2, which in lowest terms would be 2 pi. Okay, then we learned that there was only 2 number systems that we actually have to memorize or learn, and that's our 30s and our 45s. So let's look first of all at my red lines. That's the 45s. So what's happened is I've started here and I've split the top arc of my circle into 4 equal parts, into 45-degree angles. So I've got 45 degrees, 90 degrees, 135 degrees, and 180 degrees. Okay, so if I've divided that top arc of the circle, 1 pi, into 4 equal parts, that gives me my pi over 4s. So I've got 1 pi over 4, 2 pi's over 4, 3 pi over 4s, 4 pi over 4s, 5 pi over 4s, 6 pi over 4s, 7 pi over 4s, 8 pi over 4s to get all the way around the circle. Okay. Now, of course, I wouldn't leave those in as 8 pi over 4, for instance, or as 6 pi over 4 down here. I would always put them in the lowest terms. And so you can see that that does actually, in lowest terms, is the same thing as 3 pi over 2 at the bottom there, or 2 pi at our starting position here. Then if we trace my 30 degrees, which are the blue lines on my unit circle, what I've actually done is split that top arc of my circle. In other words, I've split pi into 6 equal segments, and that gives me my 6's. Okay, so when I split it into my 6 equal parts, I've got 1 pi over 6, 2 pi's over 6, 3 pi's over 6, 4 pi's over 6, 5 pi over 6's, 6 pi over 6's, 7 pi over 6's, 8 pi over 6's, 9 pi over 6's, 10 pi over 6's, 11 pi over 6's, 12 pi over 6's. And again, in lowest terms, you can see that that does equal 2 pi, or okay, so hopefully you're getting more comfortable with doing that. The reason that it is so important to know how to work with the unit circle and to see those patterns on the unit circle is because it will simplify and reduce the amount of work that you have to do on a particular question that you could figure out other ways, but it would take you a good 5, 10, sometimes even 15 minutes to figure out a question that if you know your unit circle, it will take you 30 seconds to do that exact same question. And I'm going to show you what I mean by that on the next question. Okay, so it's really, really important that you know this unit circle and that you're able to use it. Okay, in fact, when you start the diploma, if I were you, I would just take out a blank sheet of paper and really quickly draw yourself the unit circle. And then you'll have it for the whole test, and that 1 minute that you take writing that unit circle, or 2 or 3 minutes that it takes you to do that, will be well worth your time, because it will drastically cut down the amount of time that it takes to do several of the questions on the exam. Okay, so last day I left you with, I purposely omitted a question on page 506. So if you could turn in your books to page 506, we're going to have a look at class example number 6. And the reason that I purposely omitted this question when we went through it the other day was because I wanted you to be really comfortable with the unit circle so that you could see how knowing it will just help you answer this question in a matter of seconds. There are other ways to calculate this question and figure it out that would take you considerably longer. But if you know your unit circle, it will make it a breeze. Okay? So number 6 says, Determine the reference angle for the following rotation angles. And the first one is 4 pi over 3. Well, I don't know my pi over 3's, but I do know my pi over 6's. So first of all, I'm just going to convert this to pi over 6's. So in the bottom, I'm multiplying by 2. So in the top, I'm going to multiply by 2. That's the same thing as 8 pi over 6's. Okay? And then always, always, always draw it every time. Make yourself a note of that here. Okay? So if I draw this, I need 8 pi over 6's. So what that means is I'm dividing that top arc of my circle into 6 equal parts. So let's count around until we get to 8 pi over 6's. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'm going to put an arrow on the end of that last line so that I remember that my angle actually started here, and this is the terminal arm of my angle where I ended. Okay, so my angle is actually this angle right here. Okay, now because this is an obtuse angle, I can figure out the reference angle for this angle, and that's this angle right here up to the x-axis. Well, I can see right off at a glance that if each one of these sections that I've marked off are pi over 6's, then my reference angle is actually 2 pi over 6's, right? And in lowest terms then that would be pi over 3. So I've done that whole question in a matter of probably 30 seconds because I knew my unit circle. Now there are other ways to do it. I can figure out coterminal angles and go through a whole bunch of other steps. But if I know my unit circle and I can just draw it and I can just look at it and see that this reference angle here is 2 pi over 6's, then I've got my answer right there at a glance. Okay, let's try that for the next one. This is negative 5 pi over 4's. Okay, well, let's draw it because every time we're going to draw it. Now it's negative, which means I'm going in a clockwise direction around the other way, but I need to mark off pi over 4's and just count them. 1, 2, 3, 4, 5. So I'm ending right there. This means that my angle is starting here, it's ending there, and I'm going in a negative direction. This is the angle. Okay. Now again, at a glance, I can see that my reference angle is that one right there. My reference angle is 1 pi over 4. Right? Because this is a pi over 4, 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 and this is a pi over 4. Each one of those is 1 pi over 4 chunk or section. Now, if you go to diploma prep, they probably would show you this same question in a lot more detail because there are lots of other ways to figure it out. So I'm just going to show you another way that you might figure this out, but you'll see that it takes a lot more time than what we just did right there because we knew our unit circle. Okay, so we could figure out the positive coterminal angle because, in other words, right now this angle here is an obtuse angle and I need the reference angle here, and so the other way to calculate this would be to figure out what this angle is here, the coterminal angle that shares this terminal arm, and then I can use my regular way to figure out, well, if I know that this whole distance here is pi, then I can just subtract this little coterminal angle and then I'll be left with this reference angle. Okay, so that's the other way to do it. It's going to take a lot more work, but it's possible to do it that way. So what I would have to do to get this coterminal angle here is I'd have to say, well, my original angle is negative 5 pi over 4. Now to get the coterminal angle for that, I'm going to have to add 1 full rotation around the circle, okay, to get a positive coterminal angle. So I'm going to have to add, well, technically I'm adding 2 pi. Well, but the problem is this is over 4, and in order to add fractions, I need to have common denominators. So I need to figure out what 2 pi is over 4. 2 pi over 1 is what 2 pi is. So over 4 and multiplying by 4, that's the same thing as 8 pi over 4, right? So I'm adding 8 pi over 4, and when I do that, I get 3 pi over 4. So that's what this angle here is. This is 3 pi over 4. Well, if I know that this angle, this big angle here, is 3 pi over 4, and I know that the full distance around is pi, then pi minus 3 pi over 4 is going to give me this little reference angle there, right? The problem is, again, I'm subtracting, and so I need common denominators. So this is, pi is really the same thing as 4 pi over 4s, right? And so now I can subtract 4 pi minus 3 pi is 1 pi over 4. So I got the exact same answer, but you can see that it took me a lot longer to get there, to get this answer, as it did right here when I just could draw it because I knew my unit circle and I could figure out the answer in a matter of seconds. So on the diploma exam, it's going to be worth your while to know your unit circle, because every minute that you can save yourself time gives you more time to work on other questions that need a little more attention, and you won't run out of time on the exam. Okay, let's see if we can do the same thing then for C. I'm just going to erase some of this just so that I have room to write C. Okay, C is saying 23 pi over 6s. Okay, well, again, draw it every time. Now, pi over 6, that means I'm dividing pi into 6 equal parts. This is positive, so I know that I'm going in a counterclockwise direction. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. I'm ending there. See how important it is to put that arrow on my last line just to differentiate it from all my other lines that I had to use to count, and I can see where my angle ended. So I went around once, I went around twice, and I actually ended there. However, the number of rotations around is really not all that important, as long as you can see the angle that you're left with, okay, where you ended. Okay, so my reference angle then would be this little angle here, and I can see that that's just 1 pi over 6 section, isn't it? So my reference angle is pi over 6. Again, I could go through a lot more work to get that answer, but if I know my unit circle, it's beautiful because I can get that answer really quickly. Okay, so for today, our lesson is lesson number 3, actually. So if you could turn there in your books, please. We're going to talk today about trig ratios. Okay, now we learned about trig ratios in 20-1 last year. So a lot of this should just be a review for you. When we talk about trig ratios, we talk about the primary trig ratios being sine, cosine, and tangent. You remember these from last year? So this is where SOHCAHTOA comes in. We know that SO is sine is opposite over hypotenuse. Cosine is ka, adjacent over hypotenuse, and tangent is toa, which is opposite over adjacent. Okay, so let's just fill that in here. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay, and when you're trying to figure out which side is actually the opposite side, which side is actually the adjacent side, just imagine that you are this little theta and you're standing right there in the corner. The side that is directly opposite you and the side that is adjacent to you, beside you. Adjacent means beside. Okay. Okay, so that's just a review from 20-1. This year we're going to add something called the reciprocal trig functions. And so as we know, a reciprocal just means the inverse, right, of a trig function. So the cosecant ratio is the inverse of sine. The secant ratio is the inverse of cosine. And the cotangent ratio is the inverse of tangent. Okay, now this one makes sense. Cotangent sounds like it goes with tangent, okay? But how do you remember which is which of the other two? This little policeman has a little trick here that will help us remember. Each pair has only one co, okay? So there's one co per pair. So that means if this one is cosecant, it goes with the one that doesn't have the word co anywhere in its name. Secant goes with the one that does have co in it. So there's one co in each pair. Even in the cotangent one, there's one co in every pair. Okay, so if these are the reciprocal ratios of sine, cosine, and tangent, let's make ourselves this note. If these are reciprocal ratios, and we're not going to write too far to the right because we're going to have something else we're going to write over here, so keep this note kind of in the middle here. If these are reciprocal ratios, then dot, dot, dot. Let's see if we can fill them in terms of opposite over adjacent. Okay, so cosecant theta, okay, if cosecant theta is the inverse of sine theta, and sine is opposite over hypotenuse, then cosecant is going to be hypotenuse over opposite, right? You just flip-flop them. Take the inverse of them. Okay, again, secant theta then is the inverse of cosine, and cosine is adjacent over hypotenuse, then secant is hypotenuse over adjacent. And if tangent is opposite over adjacent, then cotangent is going to be adjacent over opposite. Okay, so you can see what's meant by a reciprocal function, a reciprocal ratio. It just means you just flip-flop and take the reciprocal. Okay, but as we learned last year, and this is a review again from last year, we can determine the trig ratios instead of in terms of opposites and adjacent sides. If we put it on a Cartesian plane, then we're talking about x values and y values, right? And then the r, remember, r stands for hypotenuse. Okay, so let's see if we can define sine in terms of x, y, and r. Okay, so sine is opposite over hypotenuse. So if you are this little theta here, the opposite is y over the hypotenuse, which is r. Well, then its inverse would be r over y. Cosecant would be r over y then. Okay, because these are inverses. Okay, cosine would be adjacent over hypotenuse, so it will be x over r. So its reciprocal, secant, would be r over x. And if tangent is opposite over adjacent, then it's y over x, and its inverse, cotangent, would be x over y. What would be the coordinates of this little point right here? If you're going over x and you're going up some value of y, right? The coordinates of that point are x, y. Okay, now it does say you should memorize these formulas, and yes, you can do that, but you really don't need to because it's much the same as the unit circle. They are something that you do need to know, like the back of your hand, but like the unit circle, if you can just draw yourself this really quick diagram on the corner of your blank piece of paper where you drew your unit circle, then you've got everything that you need right there to be able to determine y over r or x over r or y over x. Okay, what you draw is a positive angle in the first quadrant. Okay, and you're going to label your x value, you're going to label your y, your vertical distance, and you're going to label your r. And then you can tell just from glancing at that, and you can get all of these ratios from that. Okay, so really you don't have to memorize it, you just have to draw a positive angle in your first quadrant and label x, y, and r on it, and you'll have all of the ratios at your fingertips. Okay, let's just make ourselves a note of that. Draw this diagram, draw a positive angle in first quadrant. to determine the ratios. Okay, and again, that's something that would just take you 20 seconds, and you would have it then for all of the questions that are asking you about sine, cosine, tangent, and all of their inverses as well. Okay, so flip over your page. Hopefully this will look familiar to you as well from last year. A lot of this lesson today is a review from 20-1. Last year we talked about which quadrant each of the primary trig ratios were positive in. And so that's all this is again. We're just going to fill this in. Starting in quadrant 1. They've started for us already. So sine is y over r. And so if you look in quadrant 1, y values would be positive. R is always, always positive. In fact, let's make a note of that at the top of our page. Remember, y, your hypotenuse in other words, is always positive. Okay, so if that's the case, we've got a positive number over a positive number, so a fraction like that, a ratio like that would end up with as a positive ratio. Okay, so sine is positive in quadrant 1. Okay, now cosine is x over r. And again, in quadrant 1, our x values are positive and our r is always positive, so this gives us a positive ratio. A positive number over a positive number gives you a positive. Okay, tangent is y over x. And again, in quadrant 1, our y value is positive and our x value is positive. So this again will give you a positive ratio. What that means is that all three of these primary trig functions, sine, cosine, and tangent, would all be positive in quadrant 1. Okay, so remember, last year we came up with a little acronym that helped us to remember that, which quadrant each of the trig ratios were positive in. And so if all of the trig ratios are positive in quadrant 1, we put A, and that stands for all. Okay, let's have a look at quadrant 2. Again, sine is y over r, and in quadrant 2 our y value is positive, our r is always, always positive, so again that will give you a positive sine value in quadrant 2. Cosine is x over r, and in quadrant 2 our x value is negative, right? This is negative, but our r is always, always positive. A negative number over a positive number is going to give you a negative value for cosine. Tangent. Tangent is y over x, and again our y value here would be positive, but our x value would be negative. A positive number over a negative number is going to give you a negative overall value for tan. So in this quadrant, there is only one trig function that will give us a positive value, and that's sine. So in this quadrant 2, sine is positive. And you remember from last year, all S. What does S stand for? Suckers. I hope it's coming back to you. If not, stick with me and we'll get to it in a minute. Okay, quadrant 3, sine is y over r. And in quadrant 3, our y value is negative, but our r value is always, always positive. So that's going to give you a negative value for sine. Cosine is x over r. X value is negative, but our r is always, always positive. That's going to give you a negative value of cosine in quadrant 3. Tangent is y over x. Our y value's negative, our x value's negative, but a negative number over a negative number is going to give you a positive value, isn't it? So in quadrant 3, tangent will give you a positive value. Okay? Tangents of an angle will be positive in quadrant 3. Do you remember what the T stands for in our acronym? All suckers take. All right, let's check out quadrant 4. We've got sine, which is y over r. Y value in quadrant 4 would be negative, but our r is always, always positive, so sine will be negative in quadrant 4. Cosine is x over r. X value is positive. Our R value is always positive, so cosine is going to be positive in quadrant 4. Tangent is y over x, and our y value is negative, but our x value is positive, so again, a negative number over a positive number is going to give you a negative value for tangent in quadrant 4. So the only one that gives us a positive value in quadrant 4 is cosine. Do you remember the last letter in our acronym? All suckers take... Hopefully you remembered chemistry. All suckers take chemistry. That's how we can remember which trig ratio is positive in which quadrant. Okay, so I'm just going to scroll up just a little bit so that we can see the next questions, but hopefully we can still see enough of the chart above to be able to fill these in. Okay, sine ratios. Oh, sorry, I better back up and talk about this policeman here. What he's saying is that the reciprocal trig ratio follows the exact same rules as the primary trig ratio. So what that means is, okay, cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. Okay, so if sine is negative in quadrant 4, then so is cosecant, its reciprocal. If cosine is positive in quadrant 4, then so is its reciprocal, secant. If tangent is negative in quadrant 4, then so is cotangent, its reciprocal. Okay, so they're the same. They're the same sign. So sine ratios, sine and its inverse, cosecant, are positive where? Okay, well, all the trig ratios are positive in quadrant 1, but where else is sine positive? Right, quadrant 2. Okay, so if sine is positive in quadrant 1 and 2, then its reciprocal, cosecant, is also positive in quadrants 1 and 2. Okay, what about cosine? Where's cosine positive? Well, obviously, quadrant 1. Where else? Quadrant 4, right. And in that case, then, its reciprocal, secant, would also be. Okay, where is tangent positive? Well, obviously, quadrant 1. And where else? Quadrant 3, right. So its reciprocal, cotangent, would be as well. Okay, what about negative? Where is sine negative? Well, if sine is positive in quadrant 1 and quadrant 2, then it's negative in quadrant 3 and quadrant 4, right? So its inverse would be as well. Okay, what about cosine? Cosine is positive in quadrant 1 and 4, so it's negative in quadrant 2 and 3. And so its inverse, its reciprocal, would be as well. And tangent? Tangent is negative in quadrants 2 and 4, and so its reciprocal function, cotangent, would be negative in quadrants 2 and 4 as well. Okay, so in our textbook, they call this the cast rule. Now I find this a little bit confusing because in order to look at this acronym as the word cast, you're starting in quadrant 4 and you're going 4, 1, 2, 3. So that's why I like the acronym All Suckers Take Chemistry a little bit better, because it starts in quadrant 1, and I just don't want there to be any confusion with how we number our quadrants. So we use All Suckers Take Chemistry. Here's another one you can use: add sugar to coffee. Okay. You can use whatever works for you, but it's a quick and easy way to remember that all the ratios are positive in quadrant 1. All suckers take chemistry. Sine ratio is positive in quadrant 2. Tangent ratio is positive in quadrant 3. Cosine is positive in quadrant 4. And then, of course, their inverse, their reciprocal ratio would also be. All right, so let's flip over the page then and see if we can determine without technology whether the given trig ratios are positive or negative. Now, as Mrs. Baker would always say, draw first. Always, always, always. Okay, so, and you'll notice that some of these are listed in degree measure and some of these are listed in radian measure. Okay, so you'll have to watch that. The way that you can tell something is in degree measure is that you will see the little symbol for degree. If you don't see that, it is in radian measure. Be really careful of that because you will go back and forth in this unit all the time. Okay, so draw it first. 280 degrees. Well, it's a positive angle, so it's going in a counterclockwise direction. This is 270, so it would be just beyond that. So we've gone around to quadrant 4. And we're going to use all suckers take chemistry. So cosine is positive in quadrant 4, but sine would be negative. So sine is negative in quadrant 4. Okay, tangent of 7 pi over 6. Okay, well, again, good thing I know my unit circle because I can mark off pi over 6s easily. Let's see. I've got 1, 2, 3, 4, 5, 6, 7. Okay, I'm ending right there. So my angle is this one. Okay, and I can see that that is quadrant 3. And then I can use all suckers take chemistry to see that tangent is positive in quadrant 3. Okay, then I'm going to do cosine of 10 pi over 3. Well, I don't know my pi over 3's, but I can convert that to pi over 6's because I know my 6's and my 4's, right? So to convert to pi over 6, I'm just multiplying by 2 on the bottom, so I'm going to multiply by 2 on the top. That's 20 pi over 6's. Okay, so again, I'm going to draw it. Pi over 6's, and it's positive, so I'm going in a counterclockwise direction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 pi over 6's is going to end right there. Now, it really doesn't matter that I've gone around once and twice to get to there. All I really need to know is where did I end up? Well, I ended up in quadrant 3. And I know that all suckers take chemistry. Tangent is positive in quadrant 3, but cosine would be negative in quadrant 3. Okay, now the next one, cosecant. Well, cosecant is the reciprocal of which trig ratio? Well, if this has a co in it, then this one won't, so it's the reciprocal of sine, right? Okay, so again, I'm going to draw it. Negative 225, well, that's going to go around this way, and it's going to go right to somewhere in the second quadrant. Okay, so this is quadrant 2. And let's see, all suckers take chemistry. Sine is positive in quadrant 2, so its reciprocal would also be positive in quadrant 2. Okay, cotangent of negative 13 pi over 6. Okay, well, I can do pi over 6's, and if it's negative, I just do them the other direction. So I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm ending right there. Okay, I'm ending in quadrant 4. And I know that all suckers take chemistry. So cosine is positive in quadrant 4. But this is the reciprocal of, reciprocal of what? Well, there's only one. Oh, cotangent, so it's the reciprocal of tangent. Tangent is negative in quadrant 4. So cotangent would also be. Okay, the last one, secant of 1,000 degrees. Okay, well, that's like going 360 plus 360 plus almost 360 again. So I'm going around and around and almost 3 times, but not quite. I'm ending in quadrant 4. Okay, now I need to figure out what's this the reciprocal of? Reciprocal of secant is the reciprocal of cosine, because there has to be a co in that pair, right? Okay, so let's see. All suckers take chemistry. It's ending in quadrant 4 where cosine is positive, so then its reciprocal function would also be positive in quadrant 4. Okay, now this is the part of the lesson where you actually get to use your calculator to go back and forth between degree mode and radian mode. So I showed you this a while ago, but I just want to refresh your memory. Your calculator will calculate in either mode. So when you turn on your calculator, you'll notice that your mode button is the button right beside your second key, your yellow key. So if you click on mode, you'll see the third line down. It shows you that the calculator will calculate either in radian mode or degree mode. And you will just toggle back and forth to set it for either radian mode or degree mode. Okay, now the one that is black is the one that it is currently measuring in. So right now my calculator is measuring in radian mode. If I wanted to change it to degree mode, I have to go over to degree till that is the black one flashing and hit enter. Once I do that, then that one is the one that is highlighted black. Radian isn't anymore. Okay? Now you'll have to watch that because you will consistently go back and forth between degree mode and radian mode as you do these questions and also on the exam. So always, always, always check what mode your calculator is in for every question that you do. Because if you are in radian mode and you're trying to figure something out that is in degrees, it will give you the wrong answer. Okay, so always just get into the habit, just kind of be cognizant of that and get into the habit of checking and making sure that you are in the correct mode for the question that you're trying to answer. Okay, now I'm setting mine for radian mode because I want to show you then how you would calculate the value of cosecant 5 pi over 6. Okay, now I know that cosecant is the inverse operation or the inverse ratio of sine. So I can either take cosecant 5 pi over 6 is the same thing as 1 over the sine of 5 pi over 6. And your calculator will actually take that. Okay, so let's try that one together. Make sure you're in radian mode. Then clear and go to your clear screen. When you calculate this one, you're going to go 1 divided by and then bracket this whole amount, okay? You're going to go sine of 5 pi, and your calculator actually has a pi button, so you'll have to use the second key, and the up arrow is pi, 5 pi divided by 6. And then you'll need to put 2 ending brackets on to complete the brackets, and when you hit enter, you'll get that that answer is 2. Okay? So you can calculate it just by taking the inverse and the inverse ratio of that. Okay? The other way that you could do it is if you figured out on your calculator that the sine of 5 pi over 6 was 1/2, then the cosecant of 5 pi over 6 would be 1 over 1/2. And that would also give you the same answer, 2. Okay? So, class example number 3 asks you to use your calculator to determine to 4 decimal places, where necessary, the values of the trig ratios. Okay, so we're going to just learn how to use our calculator, how to go back and forth between degree mode and radian mode. I'd like you to make a note here that you just need to be sure you are in the right mode for each question. Okay, and you will have to go back and forth and back and forth, okay? Now don't, be very, very careful of that. If you see the degree sign, you know that you're in degree mode. If you don't see the degree sign, you're not in degree mode, you're in radian mode, okay? To 4 decimal places. I'd like you to pause the video and then do these questions and then restart the video and check your answers against mine. Okay, how did you do? I'm just hoping that nobody was tricked by D, okay, because they have chosen 90 here, sine 90, on purpose to try and trick us, because that's a very common angle measurement in degrees, isn't it? 90 degrees, we've seen that since we were in grade 4. But this is not degrees. If it was, it would have the degree symbol. So this is actually radian mode. Be very, very careful of that, okay? You will see the degree sign if it isn't measuring in degrees. If there is no degree sign, it is measuring in radians. All right, flip over the page, and we're going to talk about expressing those trig ratios in terms of the reference angle. So this just says the trig ratios for any angle are either the trig ratios of the reference angle or the negative of the trig ratios of the reference angle. Okay, so it's either the positive or the negative trig ratio of the reference angle. That's an easier way to say it. Okay. Okay, so what does that mean exactly? Okay, this is the procedure we're going to use. First step, we have to determine the sign of the ratio. So we have to determine, if we know that it is in the third quadrant, for instance, we need to know whether it's positive or negative in that third quadrant. How do we figure that out? We're going to use all suckers take chemistry. Okay, then we have to determine the measure of the reference angle, and then we just put the two together. Okay, so if the reference angle is in the third quadrant and that trig function is always positive in the third quadrant, then the reference angle will be positive in the third quadrant. Okay, so let's just give this a try. Cross example number 4. We have to rewrite these as the same trig function of an acute angle. Now the reason it says that is because cos of 7 pi over 4 would actually be an obtuse angle. And I'm going to show you that because always, 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 we're going to draw it first. Okay, so cosine of 7 pi over 4s. Okay, well, pi over 4s, I'm dividing that whole top section into 4 equal parts, right? 1, so that's my 45s. 1, 2, 3, 4, 5, 6, 7. That's where I'm ending. Our angle has gone all the way around from there to there. Okay, so this is in quadrant 4. And cosine, let's see, all suckers take chemistry. Oh, cosine is positive in quadrant 4. So what that means is the reference angle here, this little angle, would also be positive in quadrant 4. Okay, what is that reference angle though? Well, good thing I know my unit circle, because that's just one more pi over 4. So that's a pi over 4 is the reference angle. So the same trig function would mean I'm taking the cos then of pi over 4 instead of the cos of this angle. Okay, so the cos of this big rotating angle is the same as the cos of its reference angle. Okay, that's all it's saying. And because this is a big obtuse angle, I can't take the cosine of that, but I can take the cosine of this little reference angle, and they'll be the same. Okay. Okay, let's try this one. Cotangent of negative 100 degrees. This time I'm measuring in degrees. I know it's going in a negative direction, and it's going to be just past 90, so it's here. It's going this way. Okay, so I have this angle here. Okay, and all suckers take chemistry. So first of all, I know that if tangent is positive in this quadrant, then cotangent would also be positive in this quadrant. Now I can also figure out the reference angle, that's this one. So if this angle here is 100, then to get up to 180, that means my reference angle is 80 degrees. And so then I'm going to take the cotangent of 80 degrees instead of the cotangent of this angle, I'm taking the cotangent of this angle, the little acute angle, its reference angle. Okay, and the last one is sine of 11 pi over 2s. Well, again, I don't know my pi over 2s, but I know my pi over 4s times 2 times 2, so that's 22 pi over 4s. Okay, well, I'm going to draw this. It's going to look a little crazy, but it really doesn't matter. It just matters where I end up, right? Pi over 4s. Okay, dividing the top arc of my circle into 4 equal parts. That's my 45 degrees. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Oh, I'm ending right on my y-axis. Okay, that's interesting. Okay, so all suckers take chemistry. Well, would sine be positive or negative right here? Well, I know that sine is positive here, and all the trig functions are positive here. So sine is positive in quadrant 1 and 2. So in quadrant 3 and 4, either one of those, sine would be negative. So if it's right smack dab in the middle, it's still going to be negative, because anywhere in this bottom quadrants, sine is negative. Okay? Then I need to know the reference angle. Well, I can measure the reference angle because it's right in the middle, either this way, or I can measure the reference angle this way. It really doesn't matter because I have the same angle either way. I can tell by glancing at that, though, what that measure is. That's 2 pi over 4s, right? Okay, oh, but it's negative. So it would be the negative sign, not the positive sign of 2 pi over 4. Negative sign of 2 pi over 4. But that's not in lowest terms, so that's really the negative sign of pi over 2, isn't it? Yeah. Okay, so this is where figuring out, first of all, if that angle would, if the sign would be negative or positive in that quadrant, that will determine the sign here, okay? So if it is negative in that quadrant, then the sine of 11 pi over 2 would be negative sine of its reference angle, okay? That's why we said back here, it's either the positive or negative trig ratio of its reference angle, okay? The positive or the negative. And that's why you have to figure out its sign first, so that you'll know if it's the negative sign or trig ratio of its reference angle. Okay, so this video, I've had to split into 2 halves because when I recorded it for you the first time, it was too long. It was an hour long, and so the video didn't work again, and I had to re-record it for you. In fact, this is the 3rd time I re-recorded this video for you because it didn't work the 2nd time either. So I've split this video into 2 halves. So I'm gonna have you stop it there and work on these questions, numbers 1 to 4. Once you've done that, then watch the second video, which is really just very short. It's just class example 5, and then 5 and 6, I guess. And then there's another assignment, which is questions 5 to 15. I would like you to do those questions, and please make sure that they're done before class on Monday so that you're ready for our lesson on Monday.